Let's prove the theorem. Consider the image of V1, V2 and Vn and write it as a linear combination of Wi's because Wi's are basis of W. Okay, we will write as linear combination of W1, W2 and Wm. Look at the how we choose the index. This will be very useful later, that nth entry, we took the first index corresponding to index of W and second index of A corresponding to VI's. Okay. In short, we can say that TVI is equal to summation I varies from 1 to M A Ij W I. Okay. Vj, sorry. This is the general formula we have chosen, and where I move from 1 to n because there are n elements in the basis of V alpha. After this, now we consider any element of V. Let V belongs to V. Then we can write it as a linear combination of elements of alpha. Say it xj, vj, and j varies from 1 to n because there are n elements, and where xi belongs to the field. Then what are these xi's? You can see that the vector x, x1, x2 dot 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 xn is actually the coordinate of V with respect to alpha. Okay. Now we will look at the image of V under T, that is TV. Then we will apply 1 to n xj vj. By the linearity of T, we will get summation will come out, and j varies from 1 to n xj t vj. And now we will write the formula for tvj here. Put the formula we got here into that. Okay, what will be that? J varies from 1 to n xj and in the next step we will take it inside, so we can write this j equal to 1 to n, I varies from 1 to m, and we can write it as xij xj wi. Since there are finite number of terms here, so we can interchange these two summation sign. So let's do that. Then what is this? This is image of T V under T, that is TV. And we have written TV in a linear combination of basis of W, that is beta. So we can write the coordinate of TV with respect to beta by taking coefficients for each Wi. So with respect to W1, the coefficient will be I equal to 1, summation j equal to 1 to m a1j, here it is 1, and this is xj. Similarly, for against W2, this is belongs to W1, this entry belongs to W2. The j varies from 1 to m a2j xj dot dot dot, and in the last entry j belongs to this belongs to wm, so this will be a vector of order n. Its dimension will be m cross 1 actually, and we can write is a sorry nj, and last entry will be a nj xj. If we expand that vector, we can see that this is a11 x1 a12 x2 plus dot 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 a1n xn. Similarly, this is a21 x1 a22 x2 plus dot 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 a2n xn, and the last entry will be am1 x1 plus dot 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 sorry am2 x2 plus dot 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 amn xn. Then we can write it as a11 to a1n am1 amn, and multiply this with x1 dot dot xn. Okay, and this is what? This is TB with respect to beta. What is this? This is B with respect to alpha. So this is the matrix of linear transformation A, and we want to characterize its column. What is the first column, what is second column, and what are nth column. So we want to identify each column. What is that? In order to understand what these columns are, recall what are they. TBI equal to summation A ji wj, j varies from 1 to m. So what are these aij? You can see that this is written in linear combination of wj. So it is coefficient of some vector with respect to basis beta. The presence of this wj indicate that it is coordinate of something with respect to beta. But what is that something? Certainly this is TBI. So if you take TBI and its coordinate with respect to beta, then it will be a1i a2i dot 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 a ni sorry mi. So what is this vector? This is ith column of matrix A, and by putting this in this equation we get T V in beta equal to A V alpha, where A is given by its column is given by TB1 with respect to beta, TB2 with respect to beta dot dot dot, TBN with respect to beta. Just write the image in columns and you get the matrix of linear transformation. The matrix A is called the matrix of linear transformation T with respect to alpha and beta, because the matrix of A depends on alpha and beta, so it is good to indicate alpha and beta in the notation of matrix of linear transformation. So we denote the matrix of linear transformation of T with respect to alpha and beta as this following notation. In some books it is also written alpha beta, something like that. So only thing we need to understand here that alpha is the basis of V and beta is the basis of W. Thank you for watching.